Assalamu alaikum wa rahmatullahi wa barakatuhu. My name is Muhammad and today we'll be doing chapter 2, lesson 2, more graphs and displays. So our objectives for this lesson is how to graph and interpret quantitative data using stem and leaf plots and dot plots. How to graph and intercept qualitative data using pie charts and Pareto charts, and how to graph and intercept pair data sets using scatter plots and time series charts. So graphing quantitative data sets. So each number is separated into a stem and a leaf, and similar to a histogram, and it still contains original data values, provides an easy way to sort data. So as you can see, the reason why it's called like a stem and leaf is like over here 2, 3, and 4 is basically like the stem, and then 1, 5, 5, 6, 7, 8, and the numbers below that are like the leaf. So it kind of that's why it's called like the stem and leaf, and it's an easier way to store data. And then after here's an example of constructing a stem and leaf plot. So we have a data set that lists the numbers of text messages sent in one day by 50 cell phone users. And then we have to display the data in a stem and leaf plot, and then we have to describe any patterns. And here are the numbers of the messages sent. So over here we say the data entries go from a low of 16 to a high of 149. And then we have to use the rightmost digit as the leaf. For instance, 76 would be like 7, and then the leaf would be 6, and for 149 it would be 14 would be the stem, and then 9 would be the leaf. So I list the stem 7 to 14 to the left of the vertical line, which basically separates from stem to leaf, and then for each data entry list a leaf to the right of its stem. So as you can see, 169, and then over here, and then all of that, 169, and then all of that. As you can see, so this would be like 16, this would be 19, and all that. And then here's a key. So for like 110 and then the vertical line 2, it would be equal to 102. And in front of the display, you can see that more than 50% of the cell phone users sent between 20 and 50 text messages. So yeah, as you can see. And then over here above that, it really just goes away. And then over here, we organize the data set in previous example using a stem and leaf plot that has 2 rows for each stem, and we have to describe any patterns. So we're going to organize it now, and we have to list each stem twice, and we use the leaves 0, 1, 2, 3, and 4 in the first stem row, and the leaves 5, 6, 7, 8, and 9 in the second stem row. Notice by that using 2 rows per stem, you obtain a more detailed picture of the data. As you can see, it's more detailed, you can see more numbers and all that. So, and then from the display, you can see that most of the cell phone users sent between 20 and 80 text messages. So, over here we have graphing quantitative data sets. So, dot plot. Each data entry is plotted using a point above a horizontal axis. So we have data 21, 25, 25, 26, 27, 28, 30, 36, 36, and 45. And as you can see, we have numbers listed from 20 to 45, and then dots representing. For example, we have 121, there's a dot on top of that. And since we have 225s, there are 2 dots on top of that. Simple as that. And then we have to use a dot plot to organize the data set in example 1, describe any patterns. And after that, here from the dot plot, you can see that most entries occur between 20 and 80, and only 4 people sent more than 100 text messages. You can also see that 149 is an unusual data entry. As you can see, it's all very populated over here. Then it later becomes smaller and smaller and smaller. So see, if between 20 and 80, this is where the normal amount is. And then later on, it just becomes like nothing. And then the high was 149, which is like only 1 person. And then over here, to graph it onto a calculator, technology can be used to construct dot plots. For instance, Minitab and StatCrunch dot plots for the text messaging data are shown below. So it's basically just doing the same thing except on Minitab or StatCrunch. And then graphing qualitative data sets, pie chart. Pie charts provide a convenient way to present qualitative data graphically as percents of a whole. A circle is divided into sectors that represent categories. The area of each sector is proportional to the frequency of each category. So an example of that would be that our numbers of earned degrees conferred in thousands in 2014 are shown in the table. Use a pie chart to organize the data. As you can see, we have the type of degree and the numbers were shown in the thousands. So we have the associates, bachelor's, master's, and doctoral. And then as you can see, and then over here we have the solution. So we have to construct a pie chart using the central angle that corresponds to each category. To find the central angle, multiply 360 degrees by the category's relative frequency. For example, the central angle for the associate's degree is 360 degrees times 0.264, which is around 95 degrees. So find the relative frequency percent of each category. As you can see, the frequency for associates would be 0.264, the relative frequency. And then same thing for bachelor's, 0.491 and all of that. And then using the formula we learned earlier from 300, so we have to do 360 times the relative frequency, which will give us the angle. And then here you can see, these are the percentages labeled here. So 0.264 becomes 26.4%. And then the angle here, this is a 95-degree angle, this right here. And then we can check using technology. You can make a pie chart on Excel. And then you can see that almost 1/2 of the degrees conferred in 2014 were bachelor's degrees. And then the graphing qualitative data sets, a Pareto chart, a vertical bar graph in which height of each bar represents frequency or relative frequency. The bars are positioned in order of decreasing height, with the tallest bar positioned at the left. So an example would be in 2014, there were these leading causes of death in the United States, where the accidents are 136,053, cancer being 591,699, chronic lower respiratory disease 147,101, heart disease being 614,348, and a stroke, which would be 133,103. And then we have to use a Pareto chart to organize the data. What was the leading cause of death in the United States in 2014? So as you can see, since it's going from tallest to shortest basically, from the Pareto chart you can see that the leading cause of deaths in the United States in 2014 was from the heart disease. Also, heart disease and cancer caused more deaths than the other three causes combined. As you can see, these are very high numbers. And then see over here. And then we have the paired data sets. So each entry in one data set corresponds to one entry in a second data set. Graph using a scatter plot. So the ordered pairs are graphed as points in a coordinate plane used to show the relationship between two quantitative variables. And an example of that would be the British statistician Ronald Fisher introduced a famous dataset called Fisher's Iris dataset. The dataset describes various physical characteristics such as petal length and petal width in millimeters for 3 species of iris. The petal length from the first dataset and the petal width from the second dataset. And then over here we're going to graph it into the data plot here. So as the petal length increases, what tends to happen to the petal width? And each point in the scatter plot represents the petal length and petal width of one flower. Over here, the x-axis is the petal length, and then the y-axis is the petal width. And as you can see, the numbers here are shown. And then from the scatter plot, you can see that as the petal length increases, the petal width also tends to increase, as you can see. And then we have another type, which is the time series, where the dataset is composed of quantitative entries taken at regular intervals over a period of time. And then an example, the amount of precipitation measured each day for a month. And we're going to use a time series chart to graph. So we have an example here. The table lists the numbers of motor vehicle thefts in millions and burglaries in millions in the United States for the years 2005 through 2015. Construct a time series chart for the number of motor vehicle thefts. Describe any trends. So as you can see, we have the numbers here. And then let the horizontal axis represent the years and let the vertical axis represent the number of motor vehicle thefts in millions. Then plot the paired data and connect them with the line segments. So as you can see, the time series shows that the number of motor vehicle thefts decreased until 2011 and then remained about the same through 2015. So you can see the peak was 2005 and it slowly decreased and then became stabilized at a normal rate. So this concludes lesson 2.2. So let's just go over a quick summary. So we're going to go back all the way up here. So we learned about the stem and leaf plot. And we learned how to graph them, and we got a few examples of that. And then we learned a dot plot, very simple, just putting dots over our x-axis of numbers. And then we learned how to put that in Minitab and StatCrunch. We learned about the pie chart, and we learned we got an example of it, and then we learned how to solve for the angle, and then we learned how to solve for the percentages, as well, and then we learned how to use it, how we put it on Excel, and then we learned about the Pareto chart, about the bar graphs, and then we got a few examples of that, and then we learned about the paired data sets, also known as a scatter plot, and we got an example of that. And then we have the time series, and we got an example of that, and that concludes this lesson. Jazakallahu khairan. Assalamu alaikum wa rahmatullahi wa barakatuh.